Welcome to Cambridge IGCSE Physics, Lesson 14.1, Three States of Matter. Today we explore the fundamental properties that distinguish solids, liquids, and gases. This core content forms the foundation for understanding matter and its behaviour in different physical states. Let's examine our learning objectives for today. By the end of this lesson, you will be able to: first, know the distinguishing properties of solids, liquids, and gases. This means understanding what makes each state unique. Second, compare properties of the three states. You'll identify similarities and differences systematically. Third, identify states from property descriptions. This skill helps you recognize states in exam questions. These objectives align with AO1, Assessment Objective 1, which focuses on scientific knowledge and understanding. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, states of matter, which means the different physical forms that substances can take. Second, solid, which means a state with fixed shape and fixed volume. Third, liquid, which means a state with fixed volume but variable shape. Fourth, gas, which means a state with both variable volume and variable shape. Understanding these terms precisely is crucial for exam success. We use SI units, the International System of Units, throughout our calculations. Let's explore our first core concept, solid properties. The fundamental principle states that solids have definite shape and volume. This means they maintain their form without external support. The key properties are: first, fixed shape. A solid does not change its shape unless force is applied. Second, fixed volume. Solids are incompressible under normal conditions. Third, high density. Particles are packed closely together. Fourth, cannot flow. The rigid structure prevents movement. Examples include ice, metals, wood, and plastic. The diagram illustrates particle arrangement in solids. Notice how particles are arranged in a regular, close packed pattern. This arrangement explains why solids have fixed shape and volume. Now we examine liquid properties. The fundamental principle states that liquids have definite volume but variable shape. This means liquids adapt to their container while maintaining constant volume. The key properties are: first, variable shape. Liquids take the shape of their container. Second, fixed volume. Liquids are nearly incompressible. Third, medium density. Particles are close together but can move. Fourth, can flow. Particles slide past each other easily. Examples include water, oil, mercury, and alcohol. The diagram shows particle arrangement in liquids. Notice how particles are close together, but randomly arranged, unlike the regular pattern in solids. This arrangement allows flow while maintaining volume. Our third core concept covers gas properties. The fundamental principle states that gases have variable shape and volume. This means gases expand to fill any container completely. The key properties are: first, variable shape. Gases fill the entire container shape. Second, variable volume. Gases are highly compressible. Third, low density. Particles are far apart compared to solids and liquids. Fourth, can flow. Particles move freely in all directions. Examples include air, oxygen, carbon dioxide, and steam. The diagram shows particle arrangement in gases. Notice how particles are widely spaced and move randomly. Arrows indicate particle motion. This arrangement explains why gases are compressible and expand to fill containers. This comparison table summarizes all three states systematically. Looking at shape, solids have fixed shape while liquids and gases have variable shape. For volume, solids and liquids have fixed volume, but gases have variable volume. Density decreases from solid to gas. Solids have high density. Liquids medium density, gases low density. Flowability. Solids cannot flow, but liquids and gases can flow. Compressibility increases. Solids cannot compress. Liquids compress slightly. Gases compress easily. The key insight is that properties change systematically from solid to gas, showing increasing particle freedom and decreasing particle attraction. Let's work through our first example. The problem states: a substance has fixed volume but takes the shape of its container. It can flow but is difficult to compress. Identify the state. We are given fixed volume, variable shape, can flow, and difficult to compress. We need to find the state of matter. Step 1. Analyze volume. Fixed volume eliminates gas because gases have variable volume. Step 2. Analyze shape. Variable shape eliminates solid because solids have fixed shape. Step 3. Analyze flow. The ability to flow confirms this is not a solid. Step 4. State the answer. The substance must be liquid, as this is the only state with all these properties. Let's check. Liquids do have fixed volume, variable shape, and flowability. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, list 3 properties of solids. Think about shape, volume, density, flow, and compressibility. Question 2 is intermediate. It states, explain why gases are compressible but liquids are not. This requires you to consider particle spacing and arrangement. Question 3 is advanced. The question is, a substance fills its container completely and is easily compressed. What state is it? This tests your analytical skills in identifying states from properties. For all questions, use the property comparison table as reference. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how today's concepts apply in practice. In engineering, material selection depends on state properties. Engineers choose solids for structural support, liquids for hydraulics, and gases for pneumatics. In medicine, different states serve different purposes. Gas anesthetics for surgery, liquid medicines for injection, solid implants for bone replacement. In industry, understanding states enables gas compression for storage, liquid pumping for transport, and solid manufacturing for products. Career-wise, this knowledge leads to materials science, chemical engineering, and medical technology. In daily life, we see states everywhere. Cooking involves state changes, weather shows water in 3 states, and transportation systems use all 3 states. Let's review the solutions. For question 1, the answer includes any 3 solid properties: fixed shape, fixed volume, high density, cannot flow, or cannot compress. All are correct. For question 2, gases are compressible because particles are far apart, allowing compression. Liquids are not compressible because particles are already close together with little space between them. For question 3, the substance is gas. Filling the container completely indicates variable shape and volume, while easy compression confirms gas state. Now, exam success tips. First, use the property table for systematic comparison. Second, keywords matter. Distinguish between fixed and variable properties. Third, always explain your reasoning by stating which properties indicate which state. Fourth, avoid the common mistake of confusing liquid and gas flow properties. Both can flow, but only gases are easily compressible. Let's summarize today's lesson. The key points to remember are: first, solids have fixed shape and fixed volume, and cannot flow. This makes them useful for structural applications. Second, liquids have fixed volume, but variable shape, and can flow. This combination makes them ideal for hydraulic systems. Third, gases have variable shape and volume and are easily compressible. This makes them suitable for pneumatic systems and storage. These 3 concepts form the foundation for understanding matter behavior. For further study, practice identifying states from property descriptions using our comparison method. Review particle arrangements to understand why each state has its properties. The next lesson covers changes of state, which builds on today's work by explaining how matter transforms between these 3 states. Ensure you understand today's concepts before moving forward.